Now let's start the lecture, lessons from the 2011 Tohoku earthquake tsunami disaster. I'm Shunichi Koshimura from the International Research Institute of Disaster Science, Tohoku University. Today, I'd like to talk about what we have learned from the 2011 event. So, what I'm showing here is the tsunami inundation zone at the Sendai coast, where the Tohoku University is. So our campus is very close to the tsunami affected area. So in that sense, many faculty members, including students, have been working on the many efforts, including the recovery and reconstruction. So this is the seismicity map in the world. So thinking about the earthquakes in the world, you are looking at many earthquakes are occurred in the whole part of the world. For example, in Japan, our country is here. It's varied. You're looking at the black dots. That's the earthquakes. So our country is varied by the many earthquakes in the past. So looking at the other countries along the Pacific Ring of Fire, many earthquakes have been happened. So in that sense, we have to share the lessons of the earthquakes and the tsunami disasters. As the beginning, let me show you some numbers in terms of the statistics of the tsunami disasters in the past. 58, 260,000, 100. These are the numbers related to tsunami disaster statistics. Like in 100 years, we had 58 tsunamis that caused 260 deaths. So if you take the average of this number, for example, the number of the fatalities per event, per one single event, that is up to I think more than 4,600. So looking at these statistics, so what we can say about the tsunami disaster is that the tsunami is very rare event, but once it happens, its impact is very devastating. You know, this number is contributed by two catastrophic events, like a 2004 Indian Ocean tsunami or 2011 Tohoku tsunami. But this number is, I think, is very important to understand the characteristics of tsunami disaster. It's very rare, but once it happens, its impact will be huge. So this is the video of the tsunami attack to the Sendai coast, where I'm from. So the tsunami inundation extent was very large. That was the area of 156 square kilometers, and then the highest run-up above the sea level was up to 40 meters. And then the tsunami caused more than 18,000 more than 18,000 fatalities. That was up to the 3% of the population in the inundation zone. Building damage was up to 120,000 destroyed. And then we had 23 million tons of debris. That was up to a half of annual waste amount of Japan. Economic losses, 25 trillion Japanese yen. That was up to a quarter of annual budget of Japan. So in that sense, we call this disaster national crisis. Watching this video, it has very important lessons. For example, tsunami is not only the seawater penetration. So what you're looking at, the tsunami penetrates inland with many debris, including the floating object like fishing boats, and even the fires are generated. So it's a kind of cascade of many impacts and then many hazards. The other thing is that the question is how fast that tsunami penetrate inland. So it looks like a motorcycle on the ground. So it's very fast. So watching this video, we can analyze that how fast the tsunami penetrates inland. This is the only equation I show you this time, the speed of tsunami. That is square root of gh. G is gravitational acceleration, that is 9.8 times water depth. So if you calculate this, you can obtain the speed of tsunami propagation. For example, in the Pacific Ocean, that is in average, it's about the water depth is about 4,000 meters. So tsunami speed is calculated as about 700 kilometers per hour. That is like a jet plane. At the offshore, like the water depth is 100 meters. That is up to the speed of car on the freeway, like 110 kilometers per hour. Inside the bay, like 20 to 30 meters as a water depth. That was up to the speed of the car on the road, 60 kilometers per hour. On land, if we assume the 5 meter tsunami on land, that is the speed of the small motorcycle, 25 kilometers per hour. So the lesson is that the tsunami speed is very fast, even on the land. Why we call this kind of wave as a tsunami? In the tsunami actually is the Japanese word. Tsu means the hover, nami means the wave. So it's hover wave. Let me explain why people call that hover wave. So at the moment of tsunami generation, at the offshore, the deep area, so the shape of the water surface is very smooth. Like in vertical range, it's up to meters or 10 meters or so. And then horizontal scale, I think it's about 100 kilometers. So in that sense, the shape of the water surface is very smooth at the offshore, so that nobody can recognize that tsunami generation even if you are on boat at the offshore like this. However, in the process of coming to the coast, so as I said, that tsunami speed is expressed square root of gh, so that the deeper part propagates faster and then shallower part propagates slower. So looking at this part, so deeper part propagates faster. That means the shape of the water surface is getting shorter and shorter as consequences of the shortening of the wavelength. The tsunami height is getting higher. And then finally, at the very shallow region, like a harbor, that is going to be the very high wall of the water. So that's the reason why the old people call this kind of wave harbor wave tsunami. Now the tsunami is used as a term of as an international term, so it's very general. So thinking about how fast the tsunami propagates even in inland, so it's like a speed of the motorcycle. So the lessons we have to learn is that never go to the coast to watch the tsunami. Otherwise, you have to run faster than the motorcycle.